This is our temperature exit ticket from the temperature lesson where we experimented and explored the true meaning of temperature and what it means to make a room warm versus making a room cold, and the conversion between Celsius and Kelvin is also something we covered in that lesson. So here it says, the gas inside your car tires has a temperature of 50 degrees Celsius when you park it after driving for a few miles. So when you're driving down the road, your tires are going however many rotations per minute, there's gas trapped inside there to inflate the tires so that you have a nice smooth ride. But all of that friction and collision with the road is causing molecules to move and jungle around and be all crazy. And so when you park your car after an hour, they've had time to settle, chill a little bit, temperature of the air inside your tires has decreased to only 35 degrees Celsius. So that temperature change is about 15 degrees. And one thing we looked at in this class is that in this particular live session, if we changed these to Kelvin, we would have 50 plus 273, which is 323, I believe, and 35 plus 273, which I actually need my calculator for, 273 plus 35, 308. So if we had the difference between 323 and 308, it comes out to 15 degrees C. So one thing I pointed out in this lesson is that, in fact, the Celsius and Kelvin change in temperature is consistent, but their numbers are vastly different. Okay, I digress. There's a change in temperature, 15 degrees downward, decrease. What can we imagine happening to the gas particles inside the tires during the temperature drop? The gas particles stop moving? No. Stopping movement of particles is absolute zero and has not actually ever really been reached, even in an experimental setting. The gas particle speed doesn't change as the tire air cools. Nope. Temperature, our definition that we created is that temperature is a measure of particle speed. So if we have changing temperature, we have changing particle speed. Third option, the gas particles slow down as the tire air cools. And the fourth option is they speed up as the tire air cools. So that's what we're left to contend with here. If the temperature drops, that means the molecular motion has dropped, if you want to think about it that way, or decreased. It has slowed down. Conversely, if we were going from 35, the car is now parked at 35, we're going to drive it down the street to the store. We park it at the store, the temperature of the air has increased back to 50. That would tell us that the particles have sped up. So temperature decrease, slow down, temperature increase, speed up.